All right, so these kind of equations where you'll be asked to find the angle that satisfy this equation are going to come up a great deal. And finding all solutions, so not just between 0 and 2 pi, but any 2k pi multiple. So let's go through this. So I'm going to refer to the picture for the unit circle. So I'm going to be thinking, and you can choose to do triangles if you wish, but I'm going to be thinking, what angles are they where the cosine, which is the x value of the angle, gives me negative root 2 over 2. So cosine is the two negative x values on these pi over 4 angles. So this would give us an angle of 3 pi over 4 or an angle of 5 pi over 4. So the way we encapsulate all solutions is we add on a 2k pi. I just get accustomed to using the letter k. K is any integer. So k could be 0 or 1 or negative 1 or 2. So any multiple of, or any number for k, any integer, gives me all of the solutions for these two. So there's no way to join them together. All right. So here we've got cotangent. So I like to think in terms of sines and cosines. So this is the same thing as saying cosine over sine is equal to root 3. And I know that that means that has to be this combination where the cosine is root 3 over 2 and the sine is 1/2. So they both could be positive or they both could be negative. So thinking about the unit circle, where they're both positive and the cosine is the root 3 over 2 and the sine is the 1/2 is here, the pi over 6. And then when they're both negative would be over here. So I have theta equaling pi over 6 plus any 2k pi multiple, or this one over here, which is 7 pi over 6 plus any 2k pi multiple. Oops, no fraction there. 2k pi multiple. Okay, so just because these are pi apart from each other, this doesn't happen that often, this would be equivalent, this is a fine answer, or I could say pi over 6 plus k pi. So go here, add pi, go here, add pi. So either one of these answers is fine. So if you find that I've got one and you've got another, and you don't need to change your answer to be like mine, just verify it. All right, cosine squared. So that means I need to go in and take the square root. So when I take the square root of 1, I get plus or minus 1. So I have two different equations that I'm solving. This literally is plus or minus. So cosine of theta is 1 or cosine of theta is negative 1. So when does cosine of theta equal 1? So that's at 0 or 2 pi. And thinking about it, that's just like saying 2k pi. So k could be 0, that gives me 0. K could be 1, right? So that's the answers I get from cosine of theta equaling 1. Or I also get where cosine of theta is negative 1. So when that's happening, that's going to be when theta is equal to pi plus any 2k pi multiple. So both of these here. And I box these answers, but it's not necessary for you to box answers. Okay, so here we go. So now we get into this multiple angle. So now I'm looking for the angle. So first just think of what is the angle. So I'm just going to say what is the angle to theta have to be so that the sine is equal to 1/2. So the sine is the small positive y value. So that's here and here. So that's pi over 6, or the angle to theta is 5 pi over 6. Okay. At this point, right now, really important, you need to add on the 2k pi. Then finish solving. So now, by dividing through by 2, I get theta is equal to pi over 12 plus k pi. And from here, I'll get 5 pi over 12 plus k pi. So these are the solutions. So it's really important you add on the 2k pi before you go finishing for the angle theta. So a little bit of a difference. So now it's divided by 2. So let's think about where this is. So cosine of theta is negative 1 is back here. So the angle theta over 2 will equal pi plus 2k pi. So only back here at pi. So multiplying here by 2, I'm going to get plus 4k pi. So again, make sure you add on this 2k pi before you finish solving for the angle. All right, so here I have a number in front, so let's go and divide that through first. So that gives me -2. So now I'm looking for the angle that when I take the cosine, I get -2. Well, that doesn't happen because it's a unit circle. So it never gives you the answer of -2. So no solution. All right, so similar here. This one will be able to go further. So I'll have -√2 over 2. So I'm thinking on my unit circle where the sine, the y value of the ordered pair, is -√2 over 2. So I know that this angle theta over 3 has got to be 5 pi over 4, or this angle here has to be 7 pi over 4. So you need to write them separately like this. Then add on the 2k pi. Then go and solve for the theta. So in this case, I'm going to be multiplying by 3. So 15 pi over 4 plus 6k pi. And this one, 21 pi over 4 plus 6k pi. Okay, so what I want to make sure that you don't write is theta over 3 is 5 pi over 4, and then comma 7 pi over 4 plus 2k pi, because that's incorrect. Because that's just saying this has the 2k pi added to it. So this is, don't write this because this is not correct math. I know what you mean, but you need to write what you mean. So you have to write 2 separate lines and then get 2 separate solutions like this. So we're going to be pretty specific because I want you to have the correct answer where this does not give you the correct answer. All right, here we go. So cosecant, I like to think in terms of sines and cosines. So I'm going to rewrite this as 1 over sine. Then I'm going to cross multiply. So I get to this. So when is sine equal to 1? That's at pi over 2. Oops, so I don't need, so sine is equal to 1 at pi over 2. So this angle 3 theta equal pi over 2 plus any 2k pi multiple. So divide through by 3, I get pi over 6 plus 2k pi over 3. So there's my solution. Okay, another one here. So cosine of theta over 3 equaling -1/2. So let's make sure we've got that. So that's back here and back here. So this theta over 3 is going to equal 2 pi over 3 plus any 2k pi multiple. Or it could be 4 pi over 3 plus any 2k pi multiple. So again, finish solving for theta. So theta equal, multiplying by 3, I get 2 pi plus 6k pi. And here, multiplying by 3, 4 pi plus 6k pi. So these are the answers. Okay. So one more here. So sine squared. So you know you need to square root. So I'm going to get sine of 3 theta is equal to plus or minus 1. So 2 things to solve for. So what angle is it that sine gives me a positive 1? That's going to be a pi over 2 plus 2k pi. So dividing by 3, I get pi over 6 plus 2k pi divided by 3. Here, I'm going to get 3 pi over 2 plus 2k pi. So dividing by 3, pi over 2 plus 2k pi over 3.